Okay, so this is our first topic of computer science hardware part 2. So microprocessor introduction. When we say microprocessor, there is generation table available for microprocessor. It starts with 1971 and the data as per book is up to 1982. First microprocessor was 4-bit, so known as 4004, used in calculator and arithmetic functions. Then second was 8-bit, used for CPUs, in which there are 3 companies, Intel, Motorola and Zilog, Z80. Then third generation introduces CPU based 16 and 32-bit CPU known as Intel 8086, 186 and 286. And after that, fourth generation introduced 386. So after 386, 486 and 586 were the 5th and 6th version. But as per your portion, you are supposed to keep in mind that up to 4th generation you are supposed to mention the thing. Now let's understand with some pictures. When you say microprocessor, where is the microprocessor located? Microprocessor is actually on motherboard. You can see multiple chips, but one chip along with fan and cooling structure. So that particular processor is CPU processor, and that CPU processor is known as microprocessor. So microprocessor is a computer processor. What actually work he is doing? He is processing data for logic and control included in single IC. So IC is integrated circuit, and the microprocessor contain arithmetic, logic, control circuitry requirement functions which are based on computer CPU. So graph wise, if I want to show you how computer is working, processor is working, so this is a general functional block in which ALU is placed in this area, and as you can see, this is one internal data bus which is connected with multiple arrows. Then this is data address bus buffer, and this is address buffer. So 8 plus 8, 16. Then this is one, you can say, IC chip. Pins are included and every pin will have some activities. Then this is instructor decoder and machine cycle encoding. This is instruction register, which include this 8-bit register in which A is accumulator, BC is 1 pair, DE is 1 pair, HL is 1 pair. Stack pointer, program counter and increment decrement latch. So this is one structure which we use in 8-bit register, and we will going to do multiple instruction set program based on this register and how to save memory in this register, that we will going to learn in next topic. So accumulator, temporary register, instructor register and multiplexer are in one level, but they all are going to give direction signal to different area. Okay. So the primary function of CPU is to fetch, decode and execute the program in the proper order. Transfer of data to and from memory and to from the input output section is the task. So whenever you want to give any data to computer, what generally you people do? You use keyboard and mouse input device and you type something. Immediately when you type something, keyboard will decode it into machine language and the data will be go to processor to process it. Once the data is processed, again it will be converted into human language and then it will show on output like monitor. So these all activities require a processing level or processing step which is done by CPU, and CPU will have this particular organizational structure in which the arithmetic and logic unit is in 8-bit and it performs arithmetic and logic rotate operations, and it contains binary adder, perform addition, subtraction and 2's complement method, and the result is typically stored in accumulator. Whatever final result is available, that is stored in accumulator, and accumulator, temporary register, flag register are closely associated with ALU, and the temporary register is used to hold during ALU operation. And what is flag? Flag will going to give you status of signal or circuit is complete or not. If it is complete, known as set, and if you want to again restart, it is known as reset. So this is one reference image bought from shala.com, in which you can see this ALU, which include status register, then temporary register, accumulator, binary adder and shifter. So they all will going to combine their work and they will going to create a task which is based on this small unit. So this is the area of microprocessor where various computing functions are performed, and ALU, that is addition, subtraction, division, multiplication, and logic, that is AND or NOT, is stored. This activity is stored in this particular small chip. So when I am saying register, what is register? Register is a primary storage of data temporarily used to execute the program, and some registers are accessible to use through the instruction. So control unit, this is one more unit which will control all operations. So the word itself gives you timing and control signal of the operation. It contains flow of data between microprocessor, memory and other device, that is peripherals. So when I am saying memory, memory is divided into again two major parts. One is RAM and one is ROM. RAM is read and write, that is random access memory, which is based on this type of chip, and ROM is within that read-only memory, that is actually set by factory when you place a IC on a board. So when we see this type of memory chip, this is known as processor, microprocessor, which will going to give you this much of activities, as we already saw this block diagram, and this is the real IC photo or CPU photo, which will going to give you idea that small chips are doing so much of work, so they are called as micro. Now how to give instruction and how to store data in this memory, that we will going to learn in next topic. Thank you.